Hello children, let's continue with our chapter Matter in Our Surroundings, Part 2. In this chapter, we will study about blood states of matter. As you all can see on the screen, there are three states of matter: solid, liquid and gas. Now let me give you a day-to-day life example. For example, you are sitting in a school, in a classroom. So when you are sitting in a classroom, all the students are sitting at their respective seats. And especially when a teacher is there is no movement. You are bound to sit at your seats. At that time, the class is considered to be in the solid state. However, when the teacher moves out of the classroom and the period gets over, and the new teacher is about to enter the classroom, at that time there is a slight movement in the classroom by the students. The students can move from one place to another, from one seat to another, but they will be moving in that own classroom. The students are only allowed to move in their own rooms, in their own classrooms. At that time, the state considered to be is liquid. But when the school gets over at 1:30, then all the students are dispersed and they are supposed to board their buses. At that time, the particles or the students are moving far apart and they are boarding their buses. So at that time, the state is considered to be the gaseous state. So I hope you all can relate that in the first case you all were sitting at your seats, so that time the state was solid state. When there was no teacher and there was slight movement in the room, at that time it was liquid state. And at the time of dispersal at 1:30, you all were boarding your buses and moving out of the room at far places. So at that time the state is considered to be gaseous state. When we look at the matter around us, we find that it is in the three forms: solid, liquid and gas. These three are the physical states of matter. We can even classify our body into three states of matter. That is, bones and teeth are solids, blood and water present in our body are liquids, and air in our lungs is gaseous in state. Now let us study about the properties of these three states of matter in detail. To begin with, let's start with solid state. A solid state of matter is such a state in which particles of the matter are very close to each other. As you can see a picture on your screen, you will observe that these small circles are the particles of the solid state of matter. All these particles are very closely arranged. If you look at the arrangement of these particles, you will observe that particles are regularly arranged. These particles have fixed shape. The solid state have a fixed or a definite shape, and because it is having a definite shape, it is having a distinct boundaries. For example, just think about few things in your mind. For example, a notebook or a ruler or a pen. What do you think will happen if you will try to compress these things? Do you think you will be able to compress? No. The answer that you will get is no. Do you think that they have a definite shape? Yes. You will also observe that these articles such as pen, notebook or ruler, they are even having distinct boundaries. These solid states of matter have a fixed volume, a definite volume. And because particles are closely arranged, due to which they are rigid, solids may break under force, but it is difficult to change their shape. And because we cannot change their shape, that is why we say that they are rigid in nature. We cannot even compress the solid state of matter. That means they are incompressible. When we try to compress them, we cannot compress. Why? Because the particles are closely arranged. Particles have a regular arrangement. So we cannot compress them because there is no space between the particles of the solid state. The intermolecular spaces, that means the spaces between the particles or the molecules, is negligible. As a result, we cannot compress them. As a result, they are hard. Yes? If we talk about the force of attraction, all the particles, when they are close to each other, they exhibit force of attraction. They will attract one particle. Another particle will attract the third particle. Because they are closely arranged, so they even have the maximum intermolecular force of attraction. But space between the particles is minimum. These particles, they do not show the property of diffusion. We have already done in our first part of this chapter about diffusion that intermixing of the two states is known as diffusion. When we intermix the particles of two different states of matter, that is known as diffusion. When we try to diffuse the particles of solid state into another state, we cannot diffuse, or we can say that there is negligible diffusion. Now let me give you an example to make you understand this. For example, a teacher is writing on the green board, and after 15-20 days she tries to erase it. What will she observe? She will observe that there are some traces of chalk pieces left on the green board, and the teacher is trying to rub the board, but she is not able to completely rub the board, or neatly she cannot rub the board. Why? Because traces of chalk pieces have diffused in the green board. That is why they normally do not show the property of diffusion. If kept for a long period of time, they might show negligible diffusion. Okay, children? Now let me take another example. As you can see on your screen that there is a wooden slingshot with a rubber band. Now rubber band is solid. When you stretch it, rubber band will change its shape. But that shape is changed when subjected to outside force. Solids have a tendency to maintain their shape, but they can change their shape when subjected to the outside force. So when we are providing force to the rubber on the wooden slingshot, then we will observe in the second picture of the wooden slingshot that the rubber band is stretched. But when we release it, when we leave it, we will observe that it regains its shape. That is only possible when force is removed. However, in certain cases, you will even observe that if excessive force is applied, the rubber band will break. So, remember, the rubber band, although it is solid, but it can change its shape under force. And it regains its shape when force is removed. The solids have fixed and rigid shape because the particles are very close to each other. Since they have the regular arrangement, so that is why particles are not able to move. Moreover, the kinetic energy of these particles is very less. That means the particles are not in the state of motion. That is the reason solids have fixed and rigid shape. Particles, they try to vibrate or wiggle but generally do not move. Another example, if we talk about, we can take a sponge. As you can see on the screen, children, the sponge is there with the pores. Now we are saying that sponge is solid, but we can compress. Although we have said that solids are incompressible, but sponge we can compress. The reason behind is that in the case of sponge, there are small pores within them. As you can see that there are small pores into it. These pores are filled with air. Now what happens in the case of sponge is, when we try to press it, the air which is present in the pores expels out, and so we are able to compress. But when we release it, the pores are again filled with the air. The pores are again filled with the air. Because of the presence of the air, the sponge is light. So children, remember, we are able to compress the sponge because it is air filled into it. So air makes it light, and so we are able to compress it, although it is solid in state. Another example is, if we talk about salt and sugar. Salt and sugar, if we are taking them and if we take the shape of the container in which they are placed, we will observe that their shape of the crystals do not change. Whether you can take any shape, the size of the salt crystal or sugar crystal will remain the same. Hence, they are considered to be solid. The size of this sugar or the salt crystal is so small, so minute, that individually we do not see any change in the crystal. The shape of each individual sugar or salt crystal remains fixed. Whether you take it in your hand, you take it in a jar, you take it on a plate, the size of the salt or sugar crystal do not change, as a result of which they are solids. So solids, they diffuse negligibly. So diffusion in solid occurs when an individual atoms keep vibrating. As I've already discussed the example of the chalk and the green board, when we will write onto it and we will not erase it for 15-20 days, we will observe that traces of white chalk particles will be there in the green board. So the diffusion has taken place but negligible or over a period of time. So remember children, the diffusion in solid occurs when an individual atom keeps vibrating and individually it moves within the material. Now let's begin with the liquid state. We have observed that in the case of liquid state, the particles have fluidity. Let us pick up an example of a liquid, say water or milk or cold drink or cooking oil, anything we can take it in the liquid state. All these are in liquid in state. So what will we observe? That if we try to put them on the floor, they will immediately flow because they have the fluidity. You can put these liquids anywhere, on the floor, on the table, and you will observe that they will flow. Do you think that their shape will remain the same? No, their shape will not remain the same. When you will put them on the table, their shape will not remain the same. In fact, if you take cooking oil and from a big jug you're putting it into a small bowl, do you think shape will change? Yes, they will flow immediately and that shape will change. So the shape changes in such a way that it is taking the shape of the vessel. The liquid states have low compressibility. As you can see this picture on your screen, you will observe that there are some spaces in the particles of the liquid state. As a result, you can compress them. Although compressibility is low, but yes, you can compress them. These liquid states have a definite volume. It has a fixed volume. Have you ever noticed that whatever you are purchasing from the market, suppose you are purchasing cooking oil, so what do you say? I want 1 liter of cooking oil. So you have told them the fixed volume, that this much amount you want. Or you want 2 liters of milk. So you have given them the fixed volume. I want this much amount. Why? Because they have the definite volume. Okay, children? So remember, in the case of liquid state, they do not have definite shape. They don't have any boundaries. They are taking the shape of the container. Okay, and because of the presence of intermolecular spaces between them, intermolecular space in the case of liquid state is slightly more than that of the solids. So that is why we are saying that they are slightly compressible. Compressibility is there, but it is low. And they don't have definite shape but and boundaries, but they take the shape of the container. But what do you think that the particles which are there in the liquid state, do you think that they have the force of attraction between them? Yes. And because the particles of the liquid state have force of attraction between them, that is why in whichever vessel you are pouring them, the volume remains the same. Okay, children, particles are not too far apart. Remember, I gave you the example of the classroom when teacher is not there. The particles of the movement of the particle is there within the room. Who are the particles? The students are the particles. The students are moving within that confined room. So force of attraction between the particles of liquid keep its volume same. In the case of liquids, the substances have definite volume. Because over here in the case of liquids, the arrangement of particle is not regular. They have no regular arrangement. And when we talk about the movement of the particles they move and then they slide past each other. I have already told you that they are taking the shape of the container. In whatever container you are storing them, they are taking its shape. But how are they able to move? When they are able to move, the particles slide past each other. When we talk about the compressibility, it is not easily compressible. But when we talk about the density of the liquids, what is density, children? Density is mass per unit volume. So when we talk about the density of the liquids is lower than that of the solids. But it is much higher than that of the gaseous state. Remember that. Okay, children? In fact, when we talk about the diffusion, these liquids, they show the property of diffusion. Because solids can also diffuse in liquids, liquids can also diffuse in liquids, and gases can also diffuse in liquids. Okay, if we talk about solids diffusing in liquids, we can take sugar dissolving in water. Sugar is solid and water is liquid. So when sugar is dissolving in water, we are saying sugar is getting diffused in the water. Because where it is going into the spaces between the water molecules. When we talk about liquid diffusing into the liquid, then we can say alcohol and water can diffuse. Alcohol is also liquid and water is also liquid. So liquids can diffuse into the liquids also easily. And when we talk about gases diffusing in the liquids, then we can say that the gases such as oxygen and carbon dioxide from the atmosphere, they diffuse in the water and they dissolve in the water. So children, do you know that due to these gases only aquatic plants and animals are able to survive? These aquatic animals are able to use the dissolved gases. So remember children, diffusion is much more in liquids than in the case of solids. And it is only possible because particles are moving and particles slide past each other. Okay children? Now children, let's understand about the gaseous state. Now there are so many gases around us, as you all can see, such as oxygen. We all breathe in oxygen. Okay. Have you ever wondered, a balloon seller is filling a large number of balloons from a single gas cylinder. So, have you ever wondered how is he able to do so? That gas is there in a cylinder and he is able to fill so many balloons. Have you wondered that is he able to fill up all these balloons using one cylinder? Yes. These gaseous states have fluidity. Fluidity means that they can flow. These gaseous states, they do not have fixed shape. They even do not have fixed volume, rather it fills the entire volume. Have you seen the cylinders? Earlier we used to use the cylinders also, the gaseous cylinders. So our LPG cylinders, which we are using at our homes for cooking, they are also having the gas into it. So these gaseous particles, they are moving from one place to the another. Because in the gaseous state, there is a lot of space between the particles. Force of attraction is minimum and intermolecular spaces between the particles is maximum. The gaseous states have fluidity. They can flow. Have you ever wondered the particles of the aroma of the food which mixes with the particles of the air, they are spreading out of the kitchen, and henceforth you get to know what your mother has prepared in the kitchen. Yes? These gaseous states have very high compressibility. As you can observe this picture on your screen, you will observe that the gaseous state particles are not close to each other. They are at some distance. They have spaces between them. And because they have spaces between them, so when we try to apply force or pressure onto it, we can compress them because they have a space between them which, when applied force or pressure onto it, can allow the particles to come closer. The gaseous state particles, they do not have definite boundaries. Neither they have the definite shape nor they have the definite volume. These gaseous state particles are the fast moving particles. They can move randomly from one place to the another place. Because these gases are highly compressible, we can even use the compressed natural gas CNG as a fuel in vehicles. Due to the high compressibility of the gases, we can fill large volume of gas in the small cylinder, and henceforth we can transport them easily. Okay children? The particles in a gas are free to move in any direction. gases have the tendency to flow. They have maximum fluidity. Okay, children. In the gaseous state, the particles can move randomly and they can move at very high speed. When they are moving randomly and at very high speed in a container, as you can see on the screen that there is a container in which gaseous particles are there and they are moving randomly. These particles, when they are moving randomly, they are hitting each other. Along with that, they are even hitting on the walls of the container. So when they are hitting on the walls of the container, then what happens is the pressure is exerted by the gas. And when the pressure is exerted by the gas, then their kinetic energy increases. So the movement of the particles take place randomly. Okay, children, the pressure of the gas is the force which is applied on the walls by the vessel. And this leads to the irregular movement of the gas particles. So remember, children, gases are those substances that do not have fixed volume. So whatever volume is there in the container, whatever space is there in the container, they are able to occupy all the space. Because particles can move randomly here and there. There is a lot of space between the gaseous substances, gaseous particles. And there is a minimum force of attraction between the gaseous particles. And this is the reason diffusion can take place rapidly. One matter can diffuse into the another matter into the gaseous state very easily because there is a lot of space. So another particles can fit easily in between the particles of the gaseous state. Therefore, diffusion in the gaseous state is maximum. That is why when you are burning an incense stick in your house, the smell is wondered in the entire house. The smell is felt in the entire house. Why? Because particles or the aroma of the incense stick, the particles of the incense stick have mixed with the particles of the air. And air is moving everywhere. So the particles have diffused and so you are able to identify that the incense stick has been lit up in the house. Okay, children? So remember that in the case of gaseous state, there is no fixed shape, no fixed volume. They are very fast moving particles because the particles are having intermolecular spaces between them, that is maximum, and minimum intermolecular force of attraction between them. Now children, I have prepared a tabulation for you which is showing the comparison of the states of matter, all the three states of matter on the basis of the various properties. And this is to be done in your notebook. As you all can see that there are various properties mentioned in all the three states of matter: shape, volume, movement of particles, arrangement of particles, intermolecular force of attraction, intermolecular space, compressibility. So please take down in your notebook. Children, the table continues. This tabulation is continued from the previous tabulation and it ends up with rigidity, diffusion, density, fluidity and rigidity. So this comparison is continued. So please go through it carefully. Children, this is a flowchart I have prepared for you. And it is at a glance, you can see that the matter is divided into the three states: solids, liquids and gases. And along with that, I have made the properties so that you can have a quick recap of whatever we did in today's module. Children, now it's your turn to answer these questions. try answering these questions. Solids are generally very heavy while gases are light. So I hope you are in a state of answering these questions. Solids are having the particles very close to each other. Hence, for their mass is more. They have high density. Okay, and gases, the particles are far apart, so they have low density, students. The next question is, why are gases highly compressible? This also we've already discussed. Why solids do not possess the property of fluidity? Because the particles are closely packed. So try answering these questions, students. Now children, this is your homework. Please read your NCERT book thoroughly and do question number 3 on page 6 and question number 4 and 6 on page 12 of your NCERT book in your rough copy. Thank you.